Hi guys, my name is Peter C. Dogba Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's lecture, I will be discussing differential equation. And under differential equation, I will be particularly looking at eliminating arbitrary constants with to obtain a differential equation. So whenever a problem of such is given to you, now this problem that looks like this is referred to as a kind of functional relation. So it is like the solution of a differential equation, because we said in one of our previous videos that the solution of a differential equation is a functional relation. So this is actually a functional relation. This was gotten from a differential equation. So we want to manipulate this problem so that we arrive back at the original differential equation given. So to do that, we first need to identify how many arbitrary constants within the problem. So we have C sub 1, C sub 2, C sub 3. So the fact that we have these constants to be different, that is C sub 1 is different from C sub 2 and C sub 2 is different from C sub 3, we have clearly seen that there are three constants within the problem. And since there are three constants within the problem, the quantity of derivatives, or the number of times that we are to differentiate it, will be 3 times as well. So if there are two constants, it means you will differentiate 2 times. If there are 4 constants, we will differentiate 4 times. If there's just a single constant, you're going to differentiate 1 time. So the number of constants within the problem determines the number of times that you are going to differentiate. So let's get started. Now, so the problem says y equals to c sub 1 x squared plus c sub 2 x plus c sub 3. And we're asked to eliminate the arbitrary constants to obtain the differential equation. So we start y prime equals, so a constant times a variable. Now let's differentiate each of these expressions. So we have c sub 1 x to the second power. So we apply the power rule. Remember, the power rule says if you have x raised to the n power, y prime will be n times x raised to the power n minus 1. So n here is 2, so we bring this 2 down. We rewrite x and subtract 1 from x. Plus, now the power here is 1. So it's like saying 1 times c2, and then you have x raised to the power 1 minus 1, plus the derivative of a constant, there is just a constant, is equals to 0. So y prime now gave us 2c sub 1x plus c sub 2. Now x raised to the power 0 is just 1, so it's just c sub 2. So we've gotten the first derivative. We find the second derivative, y prime prime. So to do that, we have the derivative of this function. So it's 2c1x is just 2c1 plus the derivative of this is equal to 0. So we also have the last one, y prime 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 is just equals to the derivative of a constant, which is equal to 0. So this clearly shows that we have the differential equation to be equal to 0. So this is how we find the differential equation given a relation to carry on elimination of arbitrary constants. So thanks also much for watching. See you in our next video.